This is The Hidden Life of Trees by Peter Wolby. We're in Chapter 11, Trees Aging Gracefully. Before I talk about age, I would like to take a detour into the subject of skin. Trees and skin? First, let's approach the subject from the human point of view. Our skin is a barrier that protects our innermost parts from the outer world. It holds in fluids. It stops our insides from falling out. And all the while, it releases and absorbs gas and moisture. In addition, it blocks pathogens that would just love to spread through our circulatory system. Aside from that, it is sensitive to contact, which is either pleasant and gives rise to the desire for more, or painful and elicits a defensive response. Annoyingly, this complicated structure doesn't stay the same forever, but gradually sags as we age. Folds and wrinkles appear so that our contemporaries can playfully guess how old we are, give or take a few years. The necessary process of regeneration is not exactly pleasant either when looked at close up. Each of us sheds about 0.05 ounces of skin cells a day, which adds up to about a pound a year. The numbers are impressive. 10 billion particles flake off of us every day. That doesn't sound very attractive, but sloughing off dead skin is necessary to keep our outer organ in good condition. And in childhood, we need to shed skin so that we can grow. Without the ability to renew and expand the covering nature gives us, sooner or later, we will burst. And how does this relate to trees? It's just the same with them. The biggest difference is simply the vocabulary we use. The skin of beeches, oaks, Spruce Co. is called bark. It fulfills exactly the same function and protects trees' sensitive inner organs from an aggressive outer world. Without bark, a tree would dry out, and right after the loss of fluid, fungi, which have no chance of survival in healthy, moist wood, will go to town and start breaking everything down. Insects also need lower moisture levels, and if the bark is intact, they are doomed. A tree contains almost as much liquid inside it as we do, and so it's unappealing to pests because they will quite simply suffocate. A break in its bark, then, is at least as uncomfortable for a tree as a wound in our skin is for us. And therefore, the tree relies on mechanisms similar to the ones we use to stop this from happening. Every year, a tree in its prime adds between 0.5 inches to 1 inch to its girth. Surely this will make a bark split. It should. To make sure that doesn't happen, the giants constantly renew their skin while shedding enormous quantities of skin cells, in keeping with trees' size in comparison to ours. These flakes are correspondingly larger and measure up to 8 inches across. If you take a look around, on the ground under trunks in windy, rainy weather, you will see the remains lying there. The red bark of pines is particularly easy to spot, but not every tree sheds the same. There are species that shed constantly. Fastidious people would recommend an anti-dandruff shampoo for such cases. Then there are others that flake with restraint. You can see who's doing what when you look at the exterior of a tree. What you see is the outer layer of bark, which is dead and forms an impervious exterior shell. This outer layer of bark also happens to be a good way of telling different species apart. This works for older trees anyway, for the distinguishing characteristics to have to do with the shapes of the cracks, or you could say with the folds and the wrinkles in a tree's skin. In young trees of all species, the outer bark is as smooth as a baby's bottom. As trees age, wrinkles gradually appear, beginning from below, and they steadily deepen as the years progress. Just how quickly this process plays out depends on the species, Pines, oaks, birches, and Douglas firs start early, whereas beeches and silver firs stay smooth for a long time. It all depends on the speed of shedding. For beeches, whose silver-gray bark remains smooth until they are 200 years old, the rate of renewal is very high. Because of this, their skin remains thin and fits their age, that is to say, their girth, exactly, and therefore doesn't need to crack in order to expand. It's the same for silver firs. Pines and the like, however, drag their feet when it comes to external makeovers. For some reason, they do not like to be parted from their baggage, perhaps because of the additional security a thick skin provides. Whatever the reason, they shed so slowly that they build up a really thick outer bark, and their exterior layers can be decades old. This means the outer layers originated at a time when the trees were still young and slim, and as the trees age and increase in girth, the outer layers crack way down into the youngest layer of bark that, like the bark of the beeches, fits the girth of the tree as it is now. So the deeper the cracks, the more reluctant the tree is to shed its bark. And this behavior increases markedly with age. The same fate catches up with beeches when they pass middle age. This is when their bark starts to get wrinkles, starting from the bottom up. As though they want to broadcast this event, they set to work getting mosses to colonize these nooks and crannies, where moisture from recent rains linger to soak the plush cushions. You can estimate the age of beech forests from quite a distance. The higher the green growth is up the trunk, the older the trees. Trees are individuals, and their predisposition to wrinkles varies. Some trees acquire their wrinkles at a younger age than their contemporaries. I have a few beech trees in the forest I manage that at the age of 100 are covered from top to bottom with rough outer bark. Usually, it takes another 150 years for this to happen. There's no research to show whether this is purely because of genetics, or whether a lifetime of excess also plays a role. At least a few factors are, once again, similar to the human condition. The pines in our garden are definitely deeply fissured. This cannot be because of age alone. At about 100, they have just outgrown their youth. Since 1934, the year our forest's lodge was built, they have been growing in a particularly sunny spot. Part of the property was cleared to build the lodge, and since then, the pines left standing have had more light, more sun, more ultraviolet radiation. The last causes changes in people's skin, and it appears the same thing happens with trees. Intriguingly, the outer bark on the sunny side of the trees is harder, and this means it is more inflexible and more inclined to crack. The changes I have mentioned, however, can also be because of skin diseases. In the same way, teenage acne often leaves lifelong scars, and attack by bark flies can leave a tree with a rough exterior. In this case, there are no wrinkles. Instead, there are thousands of tiny pits and pustules that never disappear, no matter how long the tree lives. Sick trees can also develop festering, moist wounds. So it is not only in people that the skin is a mirror to the soul, or state of well-being. Old trees can perform another very specific function in the forest ecosystem. In Central Europe, there are no longer any true old growth forests. The largest extensive stand of trees is between 200 and 300 years old. Until these forest preserves become old growth forests once again, we must look to the west coast of Canada to understand the role played by ancient trees. There, Dr. Zoe Lindo of McGill University in Montreal researched Sitka spruce that were at least 500 years old. First of all, she discovered large quantities of moss on the branches and in the branch forks of trees of this advanced age. Blue-green algae had colonized the trees' mossy cushions. These algae capture nitrogen from the air and process it into a form the trees can use. Rain then washes this natural fertilizer down the trunks, making it available to the roots. Thus, old trees fertilize the forest and help their offspring get a better start in life. The youngsters don't have their own moss because moss grows very slowly and takes decades to get established. Apart from wrinkled skin and mossy growths, there are other physical changes that indicate a tree's age. Take, for example, the crown, which I can compare with something I have as well. Up top, my hair is thinning. It just doesn't grow like it did when I was young. And it's the same with the highest branches up in the tree's crown. After a specific time, 100 to 300 years, depending on the species, the annual new growth gets shorter and shorter. In deciduous trees, the successive growth of such shoots leads to curved, claw-like branches that resemble fingers plagued by arthritis. In conifers, the ramrod-straight trunks end in topmost shoots, or leaders that are gradually reduced to nothing. Whereas spruce, in this situation, stop growing altogether. Silver firs continue to grow, but out instead of up, so they look as though a large bird had built its nest in their upper branches. In Germany, where stork nests are a common sight, experts call this phenomenon stork nest crown. Pines redirect their growth even earlier, so that by the time they reach old age, the whole crown is wide with no identifiable leader. In any event, every tree gradually stops growing taller. Its roots and vascular system cannot pump water and nutrients any higher because this exertion would be too much for the tree. Instead, the tree just gets wider, another parallel to many people in advancing years. The tree is also not capable of maintaining its mature height for long because its energy levels diminish slowly over the years. At first, it can no longer manage to feed its topmost twigs, and these die off. And so, just as an old person gradually loses body mass, an old tree does too. The next storm sweeps the dead twigs out of the crown, and after this cleanup, the tree looks a little fresher for a while. The process is repeated each year, reducing the crown so gradually we barely notice. Once all the topmost twigs and small branches are lost, only the thicker lower branches remain. Eventually, they die too, though they are not so easily dislodged. Now, the tree can no longer hide its advanced age or its infirmity. It's at this time, if not before, that the bark comes into play once again. Small moist wounds can become portals for fungi to enter. The fungi advertise their triumphant advance through the tree by displaying magnificent fruiting bodies that jut out from the trunk in the shape of semicircular saucers that grow larger with each passing year. Inside, the fungi break down all barriers and penetrate deep into the wood at the heart of the tree. There, depending on the species, they consume stored sugar compounds, or even worse, cellulose and lignin, thereby decomposing the tree's skeleton and reducing it to powder, even though the tree has been bravely resisting this process for decades. On either side of the wounds, which continue to expand, the tree grows new wood, which it builds up into thick stabilizing ridges. For a while, that helps to shore up the ruined structure against powerful winter storms. Then one day, it's all over. The trunk snaps, and the tree's life is at an end. Finally, you can almost hear the young trees in waiting sigh. In the years to come, they will quickly push their way up past the crumbling remains. But service in the forest doesn't end when life ends. The rotting cadaver continues to play an important role in the ecosystem for hundreds of years. But more on that later. That's the end of chapter 11. Next time we'll be going into chapter 12. Mighty Oak or Mighty Wimp?